Hello everyone, my name is Alaric Grandison, and well, I'm the programmer behind Algodal, and we created a product called Algodal Parser Generator. It's a good parser generator if you're someone who is looking to create a parser very quickly. It's designed for speed, simplicity, and just basically something that can create any type of parser. So let me go ahead and give you a better introduction to this parser. Okay, let me make sure that you can see my screen. So this parser generator tool, it generates parsers in the C language. This is good even if you don't use C, because you can easily create a binding for it. And the flavor of C that it uses is C99. So it's C99 compliant code. So not C89. If you use C89, nope, I'm sorry, it's C99. One of the best things about this parser is that it's designed from the ground up to support UTF characters. So if you're parsing a UTF-8 string, the parser generated by this parser generator will parse that, no issues. If it's regular ASCII, parse the same way, because regular ASCII is a subset of UTF-8. It's incredible how quickly you can create a parser with this parser generator. The language is so simple, is that, as an example, you can literally create a fully compliant JSON parser with literally 35 lines of code in just 30 minutes. It's just that easy. And basically, who needs these parser generators? App developers, game developers, library developers, research scientists, basically anyone who needs a parser, and more specifically, anyone who needs a parser very quickly. The app that you use to generate the parser can run on both Linux and Windows. The C code that it generates can generate pretty much on any it can generate on any platform that has a C compiler that supports C99. Officially, we support Linux and Windows. When we say Linux, we're specifically referring to Ubuntu. It should work for other flavors of Linux. If you're compiling the parser, that is the app itself that generates the parsers, it has only been tested on Ubuntu. Hopefully it works on other flavors, but it's only been tested on Ubuntu. So features, what makes this better than other parser generators? More simple source language, faster to write a parser, faster to edit a parser, can build more complex parsers with it. Generated parsers are faster. Generated parsers are in C, mother of languages. Generated parsers can run in threads. It's thread safe. Multiple generative parsers can be built in the same program. It supports multiple parsers, running multiple parsers at the same time. In the same program. It's supported out of the box. Can be compiled. The parser can be compiled for both Windows and Linux officially. But unofficially, the generative parsers can be compiled anywhere as long as you have a compliant C99 compiler. The it of course it's C, so you can drop it in directly in any C++ project, and you can bind it to non-C languages. It generates the AST for you, so no extra code needed to generate AST. Well, you can use any editor of choice, but right now we only have syntax highlighting for VS Code. And here are the specifications. And current version is 2.01. We just did our 2.0 release, I think, a couple days ago. And we found a few bugs and we fixed them real quickly. If you have any issues at all, you can come to this repo. You can submit your issues, as well as we welcome any pull requests for anyone who writes any parsers. You can add your parsers here. And if you write code for post-processing, you can add it here as well. You can submit your pull request as well. We definitely support that. So what I want to do, I want to basically test out the parser. So basically I got my copy of the parser. You can get your copy here. It's just $20. We definitely appreciate the support. If you think if you find this parser generator to be useful for you, you think it's something you would want to use in your projects, please support us. We definitely appreciate it. And yeah, get your parser. So you can download the manual. You can download the manual for free. And once you pay $20, you can actually get the app for use. Let me download the manual and show you the web page version. So let me make sure that you can see. Okay, so basically, parser generator generates UTF-8 parsers in C99 code. Also, I should also note it can generate the parser in JSON as well. And it doesn't have to be in C code itself. It can be in JSON, and it then parse that JSON and to get the parser in the form that the C program wants, and then parses your text. Yeah, it's perfect for C-like languages. And very friendly license. Use this in all your projects, public, private, commercial, whatever. And we go into a little bit of explanation, a little introduction here. The manual then talks about the app, how to use it, and please support us. And it talks about the language and so on and so forth. For details, for further details on the language, you can come to the source page here. It gives you an idea of the jargon used and explain pretty much, give an idea how the parser work in the background. And here is an explanation for each and every command in the parser. How to implement it in your C code. Here it is. It gives you this describes the API for the parser. So unlike other parser generators, the parser that we generate, we have an API for it. And that's a beautiful thing because it allows you to manipulate the data that the parser generates. So a parser can generate some tokens. You can collect those tokens, do your own manipulation, write your own functions to manipulate those tokens, and then you pass it back to the parser to generate the abstract syntax tree after you manipulated the tokens. It's an amazing thing. It comes with this API, and it this parser the parsers this parser generator creates it designed it so it's so flexible for you, so that even if the parser itself doesn't do everything you want, you can add to it. So this describes the main API that you will be using when interacting with the parser, and it gives an example program of what you do. So pretty much the main functions are this function to generate your token. So you say get tokenized results, and you get your tokens in this struct. Let me make sure you can see that. So this is the main, these two functions are the main APIs. So this generates your tokens, and this generates your abstract syntax tree. And you can manipulate them however you want if you need to. These functions print them so that you can see them. So, and that's in it. And the core field or core data is the program data. That's this data right here, the program data. And they'll have it written here, but the program data is what describes your parser, and that is what you can also store as a JSON file. And I think there is an explanation somewhere. Here it is. So you can store the program as a JSON, and then you use this API to import it to as a program, and then you use that program here to generate your tokens. Amazing. So it comes with an amazing API. So, well, enough of the theory. Let's actually see the parser in action. Here is it. So you'll get, when you download it, you'll get a zip file. You'll get the app, some required libraries, the two license file. One is specifically for the app, and one is a more general license for the product as a whole. And you get two sample parsers. And let's launch the app. Launch out right out of the box. And here we go. Okay. So as you can see, let me make this a bit bigger. So as you can see, you will select the file, you can name your parser, and you can select where you want it to generate the parser. You have some flags here that you can select for more features, but in my demonstration today, I'm not going to use any of these flags. They're all explained in the manual. You can generate multi-parser samples here. So these are just samples, show you how to use multiple parsers, or how to use your parsers in threads. Not going to do that, keeping it simple. So what I'm going to do is I'm going to create. So you have to, the parser, the app doesn't handle text editing. You do that in an external text editor. I'm going to use VS Code. Let me check if I have the extension. Yeah, I do have the extension. So you can download the extension, this extension here, Algodal parser, for syntax highlighting. Okay. So let me just create a new file. I'm gonna just call it my parser. Okay. The most fundamental thing, well, with the parser, you can either write a parser that both tokenizes and analyzes, or you can write a parser that only tokenizes. So the most basic thing you can do is tokenizing. And let's start with that. So when you're going to tokenize, right? You need your tokenizer. Big tokenizer. So at basic, you can add a string literal as your tokenizer. Okay, let me just create a file like this. Let's call this my lang for language. Right, and let me test this. We got my lang text, my parser. Okay, what we'll do, so let's see here. I have my app. I'm going to point it to this file. And point it to that file. I'm not going to name it anything. It's going to give the generic name of parser if I don't name it anything. And I want to ensure that the generated parser gets generated here. So I put in the folder. So I'm going to generate. The generation was successful. So I can check here. And here's the... Okay, so now we're going to create a simple language. So let me create a simple language. Let's say pound symbol is my comment. So this is my comment. Followed by a new line is my comment. Then I can have any amount of spaces I want. Then I can have a variable. So let's say variables in my language are 3 letters, and they must be capital letters, 3, and the letters must be 3. Must be 3 of them. There can be any amount of space followed by must be an equal sign, and then there must be a number as the value, and the number must be 2 digits. And that's my language. That's the language I come across, I invented or whatever, and I must parse this language, and I really need to parse this language as quickly as possible. I don't want to write a parser by hand because it's going to take way too long. I don't want to use one of the other parser generators out there because it's just too complicated. And they don't support, they're not thread safe. I'm going to probably use this parser in a thread while I have a next program running. I want something that's thread safe. I might want to update the generated abstract syntax tree or something like that. I need something with a good usable API that makes my workflow easy. So I'm going to use the best parser generator that exists out there, and that is the Algodal parser generator tool. So this is my language. Let me add a few more stuff. And okay. This is my language. That's the root of my language, basically. Okay. And let's say I will also allow this. So it doesn't have to be separated by new lines. It's just that let's call this a statement. Each statement must be 3-letter variable followed by an equal sign followed by a 2-digit value. And this is my language. So let's parse that. So if you think about it, this tokenizer alone with string literals alone can't do the job, because how am I going to parse all of those things? Am I going to put string literals for everything? I mean, string literal for everything? Every character? I mean, this defeats the purpose of a parser. A parser is supposed to group characters in tokens, not translate characters in the exact same characters. So if I generate a parser from this, so let's generate again. And so always remember, after you generate your, if you make any changes to your source, you have to regenerate the parser. And if you regenerate the parser, you have to recompile it. And then you can run it. So as you can see, with this, it tokenized the pound symbol, the space, the T, and the H. And I couldn't tokenize anything more because I didn't define them. And basically, it fails at the very next thing that I didn't define, which is the I. Okay. So, okay, let's add actions. So the thing is, I can't just add an action like this. So let's create an action for the commit. All right. I can't just add an action like this. When I'm defining an action, it has to be defined into a phase, either token phase or syntax phase. So if I actually try to generate my parser from this, I will get an error, and it says you need to be token or syntax, whatever, right? So the token phase or the syntax phase tells the parser generator where that action will be used. So there are two phases: the token phase where the tokens are generated, and the syntax phase where the nodes or the abstract syntax tree are generated. So this action here for the comment, because I want to tokenize the comment as one token, it's going to occur in the token phase. So I'm going to put token here. So it's just the command for the token phase followed by a colon, and all the actions that follows this will be in the token phase. So this is now in the token phase. If I try to generate a parser, it I didn't save it. I have to save it, the source, of course. Okay, so we generate the parser, and as we can see, we get these errors or warnings to say that the comment action is not being used anywhere and that it's empty. Okay, so let's use it. So let's drop it in here. Sorry, only the label. And it is now our tokenizer. And what we're going to do, we're going to make all of this in a token. So we start with the pound symbol literal. Then we're going to go all up to the end of the line, the new line. So we're going to create an action called new line. And in between the new line is going to be everything that is not a new line. So it should be, this is a counter. Anything with a box is a counter. And the star means 0 or more. So there may be none, or there may be more than many. All right. So 0 to many. And everything that is not a new line. So one thing you have to understand with the language is that you have to read it from left to right, and each function has a parameter. So this is a string literal, it's a function by itself, no parameters. This is the counter function, and the counter function takes an item as its argument. All of this is an item for the counter function. So the counter function is affecting all of this. The not is a command, and it takes a single item, and this item is the not parameter. So the not is taking this as its parameter. The counter is taking the not and its argument as its parameter. If this gets any confusing to you, you can always use brackets to group them like this, so you can see clearly. If you want, you can even put a bracket here. It works the same when you group them like this. Okay, so if you, for visual purposes, you want to group them, you can do that, but it's good to practice how to read it, always left to right. So this, all of this and this. Okay, so we're saying for this we should parse a pound symbol, then as many characters that are not new line, and then finally parse a new line. So put that there, put this action as a tokenizer, save that, then we can generate it. Okay, so we're getting an error. The action new line is undefined, so we have to define new line. So let's define that. So new line is, so the thing is, for compatible purposes, if you're parsing new line, in case your parse is being compiled for Windows, you should parse for the line feed, sorry, the carriage return and the line feed. For Linux, you only need to parse for the line feed. So this is saying parse this, but if you don't find this, parse this. That's simply what it says. This, the bar means or. Okay? So, yep, that's it. Let's try and generate our parser now. It generates without any warning or errors. Okay, so let's try to generate our parser. Okay, so it generated successfully, and then we are going to run our parser. My line. That's it. Okay, and as you can see that the comment was tokenized successfully. So here's the label for the comment and the value for the comment. So it tokenized all of this successfully. Then it failed at position 2.1, and position 2.1 is right here. Right here is 2.1. So basically it's not parsing new lines. So I can add new line as a tokenizer as well. That should fix that problem. Okay, so note that we added the new line, and we can see how that works. Okay. So as we can see, it generates a token for each of the new lines. So there are two new lines here. It generated a token for each of them. Now let's do the name, the space, the equal sign, and the number. So for the name token, I can demonstrate this command one off using a string. Well, actually, let me demonstrate that using for the, actually I don't want to call it number, I want to call it value, and we're going to do one or more. So that's the counter command, and the plus means one or more, and we're going to do one of the characters in the string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We could do the same thing inside of, let's call this variable. We could do the same thing inside of variable, but there's another way to do it. We can say one of any character that matches the range of A to Z. So that works. And then we have space. And in this case, we're going to say, okay, space can be one of any character that's a literal space or a tab. Okay. Now we're going to add all of these as tokenizers. Okay. So now let's regenerate our parser. That was successful. Let's recompile it. That was successful. Let's run it again. And as we can see, everything is working. Variable, new line, space, space, space. Okay, you can see we have 4 spaces in a row. We can use a counter to combine that. So just do one or more. Generator parser. Compile and run. And there we go, we combine it. So it fails at position 48, and that's because I forgot to do the equal sign. The equal sign is very simple, so I can just use a literal string as a tokenizer, and that will take care of the equal sign. Regenerate my parser, recompile it, and there we go. Everything is tokenizing. So we tokenize the comment. Oh, we could combine the new line here. Let's combine a new line. Why not? So if we add one or more counter here like this, it will only affect this one and not affect this one. So in order to affect both, because they're separated by a OR, we have to wrap it in a curved bracket. And so that affects it all. Let's go again. There we go. So we got the comment, the variable, the space, the equal sign, the space, the value, new line, variable, space, equal, space, so on and so forth. So that's the tokenization. But in most cases, you're going to also want your parser to generate an abstract syntax tree for you. So that's where the syntax phase comes in. The syntax phase has 3 mandatory parts. So if you're gonna do the syntax phase, you must add these 3 parts. So first is the syntax phase. And okay, so let's create an action called statement. So the syntax phase must have the syntax phase with the action defined in the syntax phase. It also must have a entry point. So this is going to be the actions that starts off the parsing. And in this case, we only have one action defined in the syntax phase, so it will be statement. So the entry point can only be a syntax phase defined action. If we try to use one of the tokenizers, we'll get an error. Let's try to generate that. So okay, so the tokenizer variable is not allowed to be an entry point. So okay, and no object points found. So basically, the other required feature whenever doing analyzation is the object point. You have to define the object point, but if you don't want to, you don't have to put anything in there. And if we generate this, Okay, let's remove this guy. This is an error. And there we go. Now this is empty. So now what we want to do now is to basically define the syntax here. So these actions are used, well, rather, these actions here are used to define our tokens. These actions here are going to be used to define our syntax. So our statement is a name followed by equal sign followed by value. All right. There are spaces in between, but we want to ignore the spaces in between. How can we ignore the spaces in between? Discard of it. They can be separated by space or new line, but we can ignore those. So basically, we want to ignore the comments, the spaces, the new lines, and just focus on these tokens that really carries the information in the language. So what we can do, we can discard these tokens. If we don't discard them, we have to take in account. So if we don't discard them, we would have to write something like variable. There may be a space. There may be a space or a new line here, followed by the equal sign, and the same thing. There may be a space or equal or new line here, followed by the value. Right? We would have to take in account. But to simplify our syntax phase action, we can just get rid of tokens we don't want. Right? After we generate the tokens, we can just get rid of the ones we don't want, like this. And what this does is it discards the tokens before sending it to the analyzation phase. So which is the syntax phase. So once the tokens arrive to the syntax phase, these are no longer in the token list right here. So let me discard the tokens. Let's remove this. Let's discard the tokens and let's see what it looks like. So this is what it looks like before we discard the tokens. Now we're going to discard the tokens. All right. So let's see what it looks like. So as you can see, the comments is gone, the new lines are gone, and the space are gone. So the only tokens left in the list are the tokens that actually carry the information, and we're passing that to the analyzation phase, to the syntax phase. Okay, now let's begin. So with we discarding these tokens, we discard them, but we have to tokenize them, and then we have to tokenize them, then we discard them. All right, so with the remaining tokens, right, so we can begin. So our statement is going to be a variable followed by a equal sign followed by a number. And that's it. So let's generate our parser. Okay, sorry. The error is number is not defined. I meant to say value here. Okay, let's go again. Generated successfully. Go again and run. So as you can see, there's no error in the analyzation phase. Analyzation was done successfully, but you're not seeing anything. That's because nothing was saved in the abstract syntax tree. The abstract syntax tree is empty. So you could actually create your and complete parser with the analyzation, but do not generate any abstract syntax tree. This is useful if you just want your parser to just validate something is well defined according to the rules of the language. But if you want to maybe get the information out, you will have to generate an abstract syntax tree. That's where the object point comes in. And I hope let me get this bigger for you. So, and that's where the object point comes in. So the object point tells the parser what to save in the abstract syntax tree. So if I add something now, like for example, statement, and I generate this, I go back here, and go, you see that the statements are created. So there are 4 statements, 1, 2, 3, 4. If we go to our text, we have 1, 2, 3, 4. 4 statements. But this ain't really doing much. I can show the values here. By default, when you're using the API to print the abstract syntax tree, it does not show the value for syntax actions. But if I come here and I change a flag that says store non-terminal strings, I check that, then it will start showing it. So I can generate again, and I can compile and go. There we go. So here is it showing it beautifully. So here are the values for each statements. Okay, so that's one way to use the flags. Okay, but what if we want to break this down more? Because obviously that's the purpose of a parser. I don't want my parser to parse just this and then I have to extract the name or that. I want my parser to do that for me. How do I do that? By just adding the tokens or tokenizers here, or the tokens, as well as to the object point. So it will save the tokens in the object point as well. So I can add variable. I can add value. I can add the equal sign, but that doesn't really, you know, at that point I don't really need the equal sign. In some cases you would need the equal sign, like say if you're parsing an operation and you want to know if it's an expression or a statement. But in this case I don't need it, so I won't put it. I could put it if I want. I could actually demonstrate that and go ahead and generate my parser again and compile and go, and there we go. So we have the statement, and then it's broken down in its children. So the parser will accurately add children to parent nodes. So you know exactly like what's a child of what. So you don't have to worry about that. The parser does everything for you. So it literally generates the abstract syntax tree for you. And as you see, you broke it down into the variable, and its variables are, you add the equal sign, and the values 78, so forth. And it does this for all of them. I don't really need the equal sign in there, so I'm just going to remove it. And let's take a look at that. And go. And there we go. And I can set it back to the default where it wasn't generating strings for the abstract syntax, for the syntax defined actions. And let's generate it again and see how that looks. Okay, and there it is. So as you can see, the statement is not showing any value, but the tokens are still showing values. So this is a default behavior, but if you want the actions that are defined in the syntax phase to show values, you have to use these flags. The syntax phase actions are considered non-terminal. So that's why it says store non-terminal strings. Okay, and that's pretty much it in a nutshell. I have a parser right here, and this is how you would write parsers using this parser generator. As you can see, it's simple, compact language, very easy, very amazing, very easy to use API, very easy to understand code.